Welcome to Boiler U. I'm Jude Wolf and we're working on a new series covering the pressure controls on common steam boilers. We're going to look at their names, their functions, and how they affect the efficiency and operation of your boiler. So let's take a look at typical controls. A firing rate control, an operating pressure control, a high limit control, and in some cases a low fire hold control. Now, those are 4 different controls and they have different jobs. We're going to look at them individually. A couple tips on these controls. They look quite similar, so I'm going to differentiate them for you and give you some suggestions. First, they should have their covers on them, but we're going to take those off for our purposes. The firing rate control, if you look inside, doesn't have a switch. It has a potentiometer with a slide wiper, and that indicates that it's a modulating control, and that's what it does. It modulates and controls the firing rate control motor for the burner. Our operating pressure control can really be thought of as our first high pressure cutout because it doesn't affect the modulation. It simply shuts the boiler down when it gets to a determined pressure and then allows it to restart in most situations once we get below the differential on the switch. A high limit pressure control functions the same in the respect that it breaks the operating circuit when we attain a certain pressure in the boiler. But it's a manual reset device, which is that way because in fact it's redundant to our operating control, and if this doesn't serve its function correctly, this will shut down the boiler. Now, not all boilers, but some will have a low fire hold switch. And the point of an automatic low fire hold switch is that if somebody enables the equipment without adequate supervision, it's going to maintain the boiler at a low fire state until we get to the preset pressure, which will allow it to come out of low fire and warm the system up the rest of the way. We're going to take a close look at the firing rate or modulating control for a steam boiler. One thing that's unique about this device is that you may look at it and presume that it's a switch because our operating limit, our high limit, our low fire device are all switches, but in fact our modulating control has a different job. It doesn't actually turn the boiler on or off as much as it controls the firing rate of the boiler in a modulating fashion. So it controls where the boiler fires between high and low fire. And the way it does that is by using a bellows that is going to drive a wiper across the potentiometer. So I like to discuss this control first because it's actually the one that's doing the majority of the work in controlling the pressure of the boiler. This is the accelerator of the boiler. The operating limit, high limit, they're more like an ignition switch. It's actually turning the boiler off. But under a reasonable load for a boiler, we're not preferably doing that. We're actually throttling the firing rate, and that's the point of this job. So as such, this is typically wired with 3 wires in what we call a Series 90 configuration. And that's the native language of a Honeywell mod motor to receive that slide wire input on the majority of boilers. So this boiler has 2 settings on it. One setting is the main setting, and the second is a differential. And it says on here that the differential is additive. And what that means is that at the firing rate set on the main, that control will be commanding the mod motor to go to the high fire position. So typically I'll set this main setting slightly above the lowest pressure that I care to see on my system, because that's going to ensure that we're at full firing rate until we attain that minimum and a little bit beyond. Now, once we've attained that minimum, we do want to modulate the boiler down, and we want to do that over a controlled range. So Honeywell uses the letters A through F and minimum to set that modulation band. And they use letters because they're not Swiss timepieces, and they really don't want you to call them and say, well, I set it for a 10 PSI modulation band and it's modulating 8 PSI. They just really don't want to hear that. So they use letters instead. Ideally, we will set that differential across the widest practical band, because if we begin modulating down at 75 PSI, we may easily be able to withstand 150 PSI on the boiler if it's its maximum allowable rating, but we don't necessarily want to run the plant up to 150 before we shut the boiler down. So we're going to pick a range that we want to modulate over that gives us as broad a range to modulate as possible, because that's going to give us a more stable and slower modulation rate, which is going to be appreciated by the burner. So let's take a closer look at the modulating control in operation. I'm going to go ahead and apply pressure to the switch and watch that potentiometer. And as soon as that comes off the high fire end of the potentiometer, what we'll see is our Modutrol motor starting to drive to its low fire end. As the pressure continues to climb, that needle will continue to move until it hits the end of its travel. With that set at the minimum position, we're at 85 PSI. So we've got about an 8 to 10 PSI range of modulation with that set at minimum. They make firing rate controls that will modulate within a smaller band than that, but ideally we don't want the burner constantly ramping aggressively up and down, because that's going to affect our system pressure, our water level, and cause other concerns. So we want to modulate over as wide a band as practical. So I'm going to make some adjustments maybe to the middle of the range, and we'll look and see what our modulation range is there. Okay, so I've adjusted the differential to the maximum, which is F on this device, and we'll take a look this time and see where that wiper ends its travel, what pressure that's at for those purposes. So at 70-ish, we're starting to modulate, and I can watch that potentiometer throttle really until about 105 PSI. So at the F setting, we're really looking at a 30 PSI range that the boiler's operating at. So that's going to give us a really stable burner operation, and there's no harm in running a boiler that's rated for that pressure up to that higher pressure before shutting the boiler down. But it's not the firing rate's job to shut the boiler down, it's the operator, and we'll talk about that next week. We're looking at the operating pressure control. The operating pressure control on a boiler has sort of a name that doesn't match what it does. The operating control name would imply that it's this control's job to tell the boiler when to start and stop, and that's true, but it doesn't tell it where to actually operate at. That's the job of the firing rate control, and we discussed and looked at that last week. So our operating control, what is it doing then? It's actually our first high pressure cutout. We're turning the boiler off when we attain the pressure setting on our operating control. And we have a main setting which should be at or approximately at that cutoff point. So if I set this for 100 PSI, you would reasonably expect it to shut off at 100 PSI, but it's going to be in the vicinity. So we always want to look at our gauges when we're setting these because, like I've said before, not made in Switzerland. So we've got a main cutoff point, and we also have a differential. And the differential on an operating pressure control is subtractive. That means that if this is set for 100 PSI and we cut off at 100 PSI, then after the pressure falls that differential amount, it will allow the burner to resume operation. So anytime we're going to adjust or look at this, we need to make sure it's coordinated with our firing rate control. Because if this is set too low, we may not attain low fire with the pressure control, with the firing rate control before we shut off. And that can result in short cycling. So that's an important reason to verify the relationship between these two settings. Now I've got a multimeter here just set to beep when we go over pressure to shut the boiler down. So I've got that set for 100 psi with a differential of 12 psi, and let's just see how close they get today. Oh, and I broke at 95 psi. So let's see what pressure we come back on at. 100 psi. So we've really got a little bit of a difference between our differential here and our reading here from what the gauge says. And that's why it's so important if I want to adjust this to closely monitor the gauge while I'm doing that, so I can see the exact pressure it's going to trip at and resume at. So I always want to make sure that my pressure control does not break until my firing rate has had a chance to drive the mod motor all the way to the low fire position. And I also generally don't want my differential so large that when the burner comes back on, when the boiler comes back on, that it goes roaring up to high fire. I want it to have enough margin above where I really want to actually operate at to allow it to get to low fire and to allow it to resume operation without having to rush up to a higher pressure rating. Now, on this device itself, aside from the main and differential, we've got 3 terminals, and I've got those wired on our handy training rig to the panel so I can look at either set. But on an operating pressure limit, what we have to keep in mind is that we are trying to break the limit on pressure rise. So that switch is wired on the normally closed contact so that if there's a demand, if there's not excess pressure, the burner will run as indicated by our beeping. So because we're trying to limit the pressure and the switch is going to make on pressure rise, we want to break a normally closed contact. So those do the majority of the operations and functions in operation. And next week we'll take a look at the high limit control. We're going to take a look at the high pressure limit on our boiler. So we've looked at the firing rate, the operator, and now the high limit. And this control is what it says it is. While the operator is really our first high limit, this is our actual high limit device, which is redundant in one sense to our operating control. Its job is singly to shut the boiler off if we exceed its set point. And it's got a gauge to set our set point with a screw up top. It has no differential, because what makes this control separate and different from our operating control is that it is a manual reset. So the differential is your finger. The idea of this control is simply to provide redundancy to our operating control, to add a second level of safety on the device. Because if a boiler goes over pressure and fails structurally due to overpressure, that's about as bad as it gets in a boiler accident. So the importance of this is obvious. But where do we want to set that? If we've got our operator set to shut the boiler off at 100 psi, we obviously want this set higher, because if we have to come out and manually reset this in order for the boiler to cycle every time, well, that's just not very practical. So we want it higher than the operating control, but we want it lower than the maximum allowable working pressure of the boiler, because we want it to shut the boiler down, preferably before we lift the relief valves on the boiler, because if they lift, they may or may not reseat, and that's a whole nother ball of wax. So how much above the operating pressure control? We certainly want it set enough that in normal routine cycling of the boiler, we're not having to come out and reset the overpressure switch. If we've got big load swings and we have loads that suddenly shut off and that swings the pressure on the boiler, we may want to give it a little more margin. The idea is basically we want it to be something that brings our attention to an issue, not a routine thing. So I do like it set enough higher that I could walk in the boiler room, and if the boiler is normally off at 100 psi, I can clearly see that we're at 115 or 110, and that would cue, hey, we need to check our operating control. Also, if we do have to reset our manual reset, we want to check our operating control operation, because it may not be a fluke that it tripped. We could have a blockage or an issue with our primary pressure cutoff. So I'm going to run this pressure up, and like on this one, I've got the meter hooked up to the normally open contact, so when this trips, it should give us an audible alarm. Or will it? As I adjust the pressure upward going to that switch, it's tripped, and I can hear the mechanical switch making, but my meter is not indicating that my normally open contact is made, and that's on purpose. While I have this wired as if it would make my multimeter on pressure rise, in fact, the terminal or micro switch on the high pressure limit doesn't actually have a normally open contact. This is a decoy on my demo board for those in training. The high limit only has a common and a normally closed switch in this particular device for a very important reason. It's now impossible to miswire this switch. Because this is a manual reset control, I don't want there to be a situation where the limit is tripped and it's wired such that the burner will run. Because obviously, if it was tripped and wired incorrectly, then it would be a permanently made switch and it wouldn't serve any purpose. So in many cases, the secondary high limit or the high limit switch will have no normally open contact. And that way it just prevents erroneous wiring. We're going to talk about a low fire hold switch. Now, not all boilers will have a low fire hold switch, but it can serve a pretty helpful function. The point of a low fire hold switch is by pressure or temperature, pressure in this case, that we ensure we have a certain operating condition in the boiler before allowing the burner to release to modulate and send the firing rate up. And the obvious situation we would want to avoid is somebody enabling or turning the burner switch on a cold boiler and for it to go directly to high fire, thermally shocking the boiler. Now, this is not the best tool for the job. The best tool to prevent that is a competent operator, putting the firing rate control in manual and warming the boiler and walking the firing rate up slowly as required. But it is necessary in many cases if we have boilers that start automatically by time clocks and things like that, because it will reduce the impact of thermal stress on the boiler. Now, this switch, we are hoping to prove that we have pressure to allow us to run. And it's typically wired in a way that is a little different than our operating and high limit. These are making and breaking the burner control circuits. Instead, our low fire hold device is actually making or breaking our firing rate circuit or interfering with the automatic firing rate control. So we will wire this on the normally open contact, because when the boiler pressure rises, we want that switch to close and to allow the firing rate control to do its typical job. So I'm going to increase the pressure on this. It's set for 50 psi. And it cleanly made at 50 psi. And so if that was wired into our modulation circuit, what we would see was that once that circuit made, our mod motor could ramp up and do its job properly. Now, the proper setting for a low fire hold switch is going to vary depending on the equipment that it's on. On a low pressure cast iron sectional boiler, it may only be set for a couple psi, just enough to ensure that we're generating steam and sending some out into the system. On a typical fire tube boiler, it might be set between 10 and 25 psi to ensure that we don't just have air pressure forming on the boiler from it warming up, but high enough that we actually ensure that we're generating steam. But on a larger water tube boiler, many of those boilers aren't designed to operate out of low fire unless they're at 100 psi or higher, because it's important to get to a certain pressure and temperature for our water density to be correct, to have good circulation in the water tube boiler. So the setting on that is important, and it does relate to our application. A low fire hold switch is typically, in fact, identical physically to our operating pressure switch. These are the same model switch, and we can use them for either application using the normally closed contacts for a pressure device or usually the normally open contacts for a firing rate limiter. So the same adjustment and differential rules will apply. And once again, we always want to be looking at the gauge when we set these because they're just not super accurate. We're taking a look at our pressure controls on our steam boilers, and one of the first questions that I get is how do you identify which switch is which? Because before we go to adjusting any of these, we obviously want to make sure we know which one we're adjusting. The first and easiest to pick out really is either the firing rate control or the high limit, because they're distinctly different from the others. Our firing rate control typically has 3 thin wires going to a potentiometer and wiper, and as such, it's not even technically a switch. It's a proportioning control. So if we take the cover off and look at that, we can see it doesn't have a switch mechanism like the other devices. Our high limit is easy to recognize because it's got a manual reset button. And on the new Mercury Freestyles, that's on the front. And on the older Mercury styles, it was frequently on the top. So you may need to get a ladder to verify on a larger boiler that particular switch. Now our operating switch and our low fire hold switch can be a little trickier because in many cases it's the same model, style, shape, number, and everything. So what we need to look at if we just walk up to a boiler that's in operation is the setting on them. Your operating control, if you look at the dial on it, is typically going to be set above your firing rate control and below your low fire hold, or I'm sorry, your manual reset high limit. Your low fire hold is going to be set lower because it's designed to operate at a far lower pressure to enable the boiler to go to the modulation state. So firing rate, operator, high limit, low fire hold, that's great. So if I were to get a Sharpie and just write on the front of those, I would know exactly which was which, except it's a common oversight, those covers all come off. So if you remove all those during an inspection to unwire and remove and clean them, etc., you've lost that valuable bit of information. So if you're going to label these, I recommend putting the label on this plastic side, the metal side of the switch, so that even if we take the cover off in the future, we still have the identifying marks on each device.